Yeah. See, one note. In some of the problems, you may get RT minus S square value 0. RT minus S square value 0. If RT minus S square equal to 0 at a point, for example, A comma B, then we need further investigation. Investigation means not CBI investigation. Okay, we have to take further action. Okay, we need further investigation to check the nature of the point, to check the nature of the stationary point, Okay, just in examination you write whenever at a point, if you will get RT minus S square equal to 0, just you write down we need further investigation at that point. Okay, and what type of investigation? See, this is, for example, mostly 0 comma 0. For example, at 0 comma 0, RT minus S square value 0. Then in the small neighborhood of 0 comma 0, you evaluate the function f of x comma y. You evaluate the function f of x comma y in the small neighborhood of 0 comma 0. Means you take 0. What is on x-axis? Y value is what? 0. So take a 0.5 comma 0 or 0.2 comma 0, like that. Take some points and check the behavior of the function f of x comma y. If it is in increasing manner in the small neighborhood, then definitely it possesses increasing value, means it possesses maximum value. If it is decreasing, then it possesses minimum value at that point 0 comma 0. For example, at some point the function is positive, at some point the function is negative in this neighborhood, then there is no conclusion. Such point is called saddle point. At saddle point, neither maxima exist nor minima exist. Remember, if at a stationary point neither maxima exist nor minima exist, that point is called saddle point. Okay, what is that? Saddle point means at this point, is voice is visible? At this point,
yes sir.
Yes, sir.
There is no max or min. There is no maximum or minimum. Okay, that is called saddle point. Now, whenever this is a small topic, okay, about this saddle point, but in examination, just you write this statement is enough. Okay, if problem comes, I will tell you what type of investigation needed. This theory I will explain in that problem. Okay, next
Sir,
one.
yesterday assignment problems we got.
Yesterday
RT minus
assignment. Which problem?
f
Which problem?
of xy equal to x cube y square into 1 minus x minus y.
That problem. X cube y square into 1 minus x minus y. This is f of xy, right? So 0 comma 0, at 0 comma 0, you are getting RT minus s square equal to 0, right? Right? RT minus s square equal to 0. Then you make this statement. Further investigation is required at 0 comma 0. And what type of investigation is required? See, in the small neighborhood of 0, what is this function? F is now, what is this? X cube y square minus x power 4 y square minus x cube y cube minus x cube y cube. Then you consider on y-axis, for example, on x-axis, what is y equal to 0? Therefore, what is the function becomes? F becomes what? Y equal to 0 means everything is 0. F value is 0, right? So instead of taking on this point 0 comma 0, this is the point on x-axis. That's neighborhood means what? This is the neighborhood, some epsilon radius. So I can consider some line also. If I put y equal to x in this one, y equal to x, then what is f becomes? Y equal to x cube x square x power 5. This is x power 6. This is x power 6. Done. So x power 5 minus 2 x power 6. Okay, and x power 5 minus x power 6, this is in terms of completely x, no? X power 5 minus 2 x power 6. Take some point on this one line. At x equal to, anyway, in textbook it is solved. At x equal to, take some point 1, simple. This is 0.1 power 5 minus 2 into 0.1 power 6. 0.1 power 6. What is this value? Negative, na? Less than 0. Is it less than 0? Positive. No. This is very small now. 0.1 now. So this is 0.1 power 5. 0.1 power 5 is more than 0.1 power 6. So it is positive. Greater than 0. And if I take in small neighborhood another point, negative 1 at x equal to negative 0.1, f value is minus 0.1 whole power 5, 2 into minus 0.1 whole power 6. So definitely negative. So this is negative. So in a small neighborhood, in this small neighborhood, 0.1 and negative 0.1, the function is positive and negative. That is, in small NBD stands for neighborhoods. In small neighborhood of 0, 0, f is having nothing but oscillate behavior. F is having positive and negative signs. Positive and negative signs, which indicates neither increasing manner, which indicates neither increasing function nor decreasing function. Therefore, at 0, 0, f is not having max and min, neither maxima nor minima. That is 0, 0 is what point now? Saddle point. Okay, but in examination, no need to write all this. Just write at 0, 0, we need further requirements or further conditions are required. Next one. This is important topic now. Lagrange's multipliers method. Lagrange's multipliers method. Lagrange's multipliers method. See, previously we have seen maxima minima function of two variables, f of x comma y. For example, if function of more than two variables, that means let me consider function of three variables. If f of x comma y comma z is a function of three variables x, y, z, okay, how to calculate maxima and minima function of more than two variables? Maxima minima function of more than two variables, maybe 3, maybe 4, whatever it is, generalization, several variables, maxima minima function of several variables. And the thing is here, whenever function is function of more than two variables, then there must be a condition given. There must be given a condition which relates the variables. That means what? If f of x comma y comma z is a function of three variables and x, y, z are related by the condition, some condition, whatever, x, y, z equal to 8 or x, y equal to z square, like that. X, y, z are related by the condition. I am taking that condition as phi of x, y, z equal to c. Phi of x, y, z equal to c or 0, whatever it is. And to apply this Lagrange's multipliers method, this condition must be required. Remember, to find the maxima minima of function of more than two variables, the variables must be connected by some relation that must be given in the problem. Then only we can find maxima minima function of more than two variables. So I have to calculate what? Maxima minima of f, subject to what condition? Here we have to find maxima or minima of what function? F of x, y, z, subject to the condition subject to the condition. What is the condition? Phi of xyz equal to c. Okay, so this is one type of optimization problem. And remember one more thing, this maxima and minima, this is called extrema, or one can call extremum. One can call extremum means it may be either maximum or minimum value. Now for this, to find this maxima or minimum value, construct a Lagrange's function. Construct a Lagrange's function. What is that function? L. L stands for Lagrange's function. First, how many variables? X, Y, Z. X, Y, Z equal to. First, write the function which is to be maximized or minimized. Write the function which is to be maximum or which is to be maximized or minimized, plus lambda into write the given condition. What is the given condition? Phi of xyz minus c. Phi of xyz minus c into lambda. And here there is a lambda in L. Now L is a function of how many variables? X, Y, Z and lambda. What is here lambda? Take this as 1. Here lambda is called Lagrange's multiplier. Lambda is called Lagrange's multiplier. Lagrange's multiplier. Okay. Now what is the thing here? If I maximize L, L is maximized, then obviously F is maximized. If L is minimized, then F is minimized. Therefore, now see why I am constructing the Lagrange's function. Actually, in the problem, finding maxima, minima subject to this condition. There are two functions are there in the function. So by constructing this Lagrange's function, how many functions are here? There is only one function. What is that function? F plus lambda phi. F plus lambda phi, and that function is L. That function is L. Then what are the necessary conditions to minimize or maximize? Necessary conditions to minimize or maximize. The necessary conditions for extremum, I will write. Extremum means for maximum or minimum, are what are those? The partial derivatives of L with respect to unknowns. What are the unknowns? X, Y, Z, and lambda is also there. Therefore, dou L by dou lambda equal to 0. Dou L by dou lambda equal to 0. Okay, these are the necessary conditions. Now, how many equations here? Totally 1, 2, 3, 4 equations. How many unknowns? X, Y, Z, and lambda. Solve these equations. Solve these equations for X, Y, Z, and lambda. Then the point X, Y, Z gives the required extremum. X, Y, Z gives the required extremum. Okay, that is minimum or maximum. And there is no condition r greater than 0 or less than 0. Not at all there. What is this one? Just construct the Lagrange's function. What is it is equal to? The given function plus lambda into the given condition. Lambda into the given condition. Then for optimization, the optimization means to get minimum or maximum value. The necessary conditions are what? L partial derivatives with respect to unknowns equal to 0. Solve these 4 equations for the 4 unknowns. Okay. Now this is one case. If we have to find maximum or minimum of f of xyz subject to not one condition, more than one condition, subject to the conditions. Let me take 2 conditions, for example. 2 conditions. Phi 1 of xyz equal to c1. Another condition is also there. Phi 2 of xyz equal to c2. Then what is the procedure? Then construct the Lagrange's function. Construct the Lagrange's function. How to construct the function? Same logic. Lagrange's function L(xyz) and leave some space. And first write the original function which is to be maximized or minimized, plus Previously, lambda into what I have written? The condition minus C1. But how many conditions? Two conditions are there. Therefore, put lambda 1 here plus for the another condition, another Lagrange's multiplier, lambda 2 into phi 2 of xyz minus C2. Phi 2 of xyz minus C2. Here, lambda 1, lambda 2 are Lagrange's multipliers. Lambda 1, lambda 2 are Lagrange's multipliers. Okay, the same is extendable. If three conditions are given, one more plus lambda 3 into phi 3 of xyz minus C3, like that. And what are the conditions for maximum? The necessary conditions. The necessary conditions for extremum. For extremum, I'm not writing clearly. Understand this. Extremum are, what is the first condition? Dou L by dou x 0, dou L by dou y 0, dou L by dou z 0, and remaining unknowns 2 are there again, lambda 1 0, dou L by dou lambda 2 0. Totally 5 equations are there, and you write here L is function of what? X, y, z, lambda 1, lambda 2. Solve these 5 equations for x, y, z, lambda 1, lambda 2. Then x, y, z gives the respective or the corresponding extremum. Okay, this is the methodology, Lagrange's multipliers method. What is the use of this method? If you're required to find maxima, minima function of more than 2 variables, then we use Lagrange's method. But what is the condition? There must be a condition given which relates the variables x, y, z. Now, let us solve one problem. First one. Given x plus y plus z equal to a, find the maximum value of x to the power of m, y to the power of n, z to the power of p. Solution. So which function is to be maximized? This one, right? So first, let function of 3 variable f of x, y, z equal to x to the power of m, y to the power of n, z to the power of p. Right? And what is the given condition? Given condition which relates the variables. Given condition is x plus y plus z equal to a. Therefore, what is phi of x, y, z minus c is nothing but what? Minus c is, let me write like this. X plus y plus z minus a. Okay, is x plus y plus z minus a. Therefore, construct the Lagrange's function. Only one condition is given. Therefore, x, y, z and lambda. That's enough. What is the first? Write the theory. Plus lambda into phi of x, y, z minus c. So L is equal to x, y, z lambda. This is x to the power of m, y to the power of n, z to the power of p plus lambda into x plus y plus z minus a. Phi value is x plus y plus z. Okay. Now, the necessary conditions for extremum are same theory. The necessary conditions for extremum are, what is the first one? Dou L by dou x equal to 0. I will write. Next one, dou L by dou y equal to 0. Dou L by dou z equal to 0. And lastly, dou L by dou lambda equal to 0. Dou L by dou lambda equal to 0. Actually, dou L by dou lambda equal to 0 gives what? The condition directly. See, if I take L derivative with respect to lambda, what I am getting? This x plus y plus z equal to a. That means solve these 3 equations. Dou L by dou x equals 0, dou L by dou y equals 0, dou L by dou z equals 0, and using the condition x plus y plus z equal to a. Now first one, dou L by dou x equals 0 means what? M into x power m minus 1, y power n, z power p plus x derivative 1. Therefore, lambda will be there. This is 0. Next one, What is this? N into x power m, y power n minus 1, z power p. This is also plus lambda equal to 0, right? And third one, p into x power m, y power n, z power p minus 1 plus lambda equal to 0. And dou L by dou lambda equal 0 means what? Lambda derivative 1 and its quotient is x plus y plus z minus a equal to 0. Take this as 1, 2, 3, and this is 4, right? From 1, what is lambda equal to? Minus m into x power m minus 1, y power n, z power p. From 2, lambda equal to minus n into x power m, y power n minus 1, z power p. Done. And from 3, lambda equal to minus p into sorry, z power p minus 1, right? So equate these two first. Equate these two. I will write like this: from 1 and 2. From 1 and 2, minus m x power m minus 1, y power n, or instead of taking this, you can do in any manner by to solve this. If I take 1 by 2, what will happen? See, if I take 1 by 2, what will happen? This is I'm taking, okay, just 5, 6, and this is 7. Let me take 1 divided by 2. 1 divided by 2. So what is this? Y power n, z power p by minus n x power m, y power n minus 1, z power p equal to 1. Done. So this is what you will get. M by n will be there, 1 by x will be there, and y will be there equal to 1. So what is y by x equal to? N by m. This is one, first one. Next, 2 divided by, not 2 actually, not 1 divided by 2, 5 divided by 6. 5 divided by 6. Next, take 6 divided by 7. 6 divided by 7. That means what? What is 6 divided by 7 means what? 6 minus n. So minus n x to the power of m, y to the power of n minus 1p by, this is minus p x to the power of m, y to the power of n, z to the power of p minus 1 equal to 1. Done. So what is this is? This implies n by p, x power m gets cancelled, 1 by y will be there, and z will be there equal to 1. So z by y. What is this? Z by y equal to, z by y equal to p by n. P by n. Done. You need another one, another condition? Yes. I need x, y, z values. Anyway, I need x, y, z values compulsory. Shall I take 6 by 5 by 7? Huh?
Yes, sir.
5 divided by 7. This is minus m into x power m minus 1, y power n, z power p by minus p into x power m, y power n, z power p minus 1 equal to 1. So this is equal to m by p, 1 by x, z equal to 1. So z by x equal to how much? P by m. Done. Now from this you have to get x, y, z. From this you have to get x, y, z. So let me write one all at one side. Y by x equal to how much? N by m, or x by y. I will write x by y equal to m by n, right? Next one, y by z equal to n by p, and z by x equal to p by m. Okay. So how to solve this? To get x, y, z, I need x value, y value, and z value. Get x in terms of z is possible? Yeah. See, write every x value in terms of z, y value in terms of z. Let us see. what is this? Z by x equal to what? P by m. So what is x equal to? Mz by p, correct? Right. X value in the mz by p. Now y by z equal to n by p. Then what is y value? Nz by p. X value, y value. Okay, in terms of z, I'm taking, right? Put x, y values in equation 4. What is that 4? X plus y plus z equal to a. X plus y plus z equal to a. Fourth equation. So what is this is x value is what now? X value mz by p. This is mz by p plus y value is what? Nz by p plus z equal to a. So what is this one? Mz plus nz plus pz equal to ap. So what is the z value I'm getting now? Z equal to how much? ap by m plus n plus p. This is z value. Then what is x actually? X equal to how much? Mz by p. Now substitute this z value here. pp gets cancelled. Yeah, if I put z value here, ap by this one, pp gets cancelled. So you will get am by m plus n plus p. This is x value. Okay, let me write mz by p. Mz by p implies x equal to. Now, what is y equal to nz by p? This implies y equal to, you will get what? An by m plus n plus p. These are the x, y, z values. Okay, these are the x, y, z values. Okay, therefore, the stationary point x, y, z, which gives maximum is, you write, what is this? Am by m plus n plus p, an by m plus n plus p, and next one, what is this? ap by m plus n plus p. And what is the maximum value? And maximum value of f is, what is that? F of x, y, z. What is the function is given as? X to the power of m, y to the power of n, z to the power of p. And substitute this x value. That is am whole power m by m plus n plus p whole power m. And y value an whole power n by m plus n plus p whole power n. ap whole power n by m plus n plus p whole power p. So what is this completely? A to the power of m plus n plus p into m power m, n power n, p power p whole by m plus n plus p whole power m plus n plus p. This is the maximum value. Okay, and remember one thing. Just after solving, we are getting the points x, y, z. After getting x, y, z, immediately we are declaring that it gives maximum. As per the question. Question is what? Find the maximum value. Directly, after getting this x, y, z, we are directly taking this point gives maximum. That is the drawback of Lagrange's multipliers method. Drawback of Lagrange's multipliers method is what? After getting the stationary point, there is no checking. Whether this point really gives maximum or minimum. There is no condition is that. Whatever the point you got, that gives the required maximum or required minimum. That is the only drawback at this engineering first semester level. But in future, your CSE, no? I think in second year there will be a paper, operation research or optimization methods. There, this Lagrange's multipliers method is modified. What type of modification? After getting the stationary point, there will be a condition. Whether this point really gives maximum value or really gives minimum value. Okay, and that is called positive definite, negative definite, like that. Just I am giving hint only. Okay, make the idea. What is hint here? What is my function f of x, y, z here? X to the power of m, y to the power of n, z to the power of p. Now you have to consider what is that matrix, so called Hessian matrix. Yeah, Hessian matrix. What is Hessian matrix? Just Hessian matrix means it is denoted by h of x, capital X. In a capital X, there are three variables. It is second order partial derivative matrix, dou square f by dou x square. X stands for 1, Y stands for 2, Z stands for 3. This is 1 position means x f partial derivative with respect to x 2 times. This is 1 2 position. So you have to write like this, dou square f by dou x dou y. This is next position, dou x dou z, 1 3 position. 1 3 means what? Xz. Same logic, this is dou square f by dou x dou y. This is 2 2 position, 2 means y. This is 2 3 position, dou y dou z. Next one 3 1 position, so dou x dou z. Next one 3 2 position, dou y dou z. Next 3 3 position, dou square f by dou z square. You calculate all the second order derivatives from this function and substitute here. Evaluate h of x at stationary point at some ABC point at ABC. If at ABC you evaluate this and if principal minors, that means the first determinant is positive, second is also positive, third is also positive, all are positive, then h of x is positive definite. H of x is positive definite, and then f has minimum value. F has minimum value. These are the conditions, some conditions like this. Okay, no need, just I'm giving idea because Lagrange's multipliers method is modified and it is clearly explained in higher semesters. Okay, no need to implement this in our problems. Okay, and if it is alternately negative positive, delta 1 negative, what is delta 1 means? First 1 by 1 determinant. Delta 2 means what? First 2 by 2 determinant. Delta 3 means what? These are called principal minors. These are called principal minors. If these principal minors are alternately negative positive, then h of x is called negative definite, then it possesses maximum value. This is the theory. Now coming to another one. Yeah, see. What time is there? Yeah, a rectangular.
Sir, you said you will explain that Laplace equation one.
Yeah, I explained Laplace equation when that also I told when.
Sir, today. Laplace
Today?
equation of polar
Not
coordinates.
today. It's a very big one. Converting Laplace equation to polar coordinates. It's a very big. I will tell that problem in the classroom. You are coming on second now?
Sir, another problem.
Which one?
Phi of cx minus az, comma.
This will not get రాలేదా అది?
No, sir. I put in the group also. No one.
సరే చేసి పెడతానులేండి. నేను చేసి పెడతాను. లెట్ మీ కంప్లీట్ ది సిలబస్ ఫస్ట్. ది థర్డ్ యూనిట్ అయిపోద్ది ఈ రోజుతో. సెకండ్ యూనిట్ మనం ఉంది, సెకండే కదా, థర్డ్ యూనిట్ అనుకుంటా కదా ఇది.
Yes.
Third units.
A rectangular box open at the top. A rectangular box open at the top is to have volume of 32 cubic feet. 32 cubic feet. Find the dimensions of the box. Find the dimensions of the box requiring. Find the dimensions of the box requiring least material for its construction. Least material for its construction. Now, solution. You know what is a rectangular box? Generally birthday cakes తెస్తారు కదా, బాక్స్, ప్యాకింగ్ బాక్స్ ఉంటుంది చూడండి, that is called rectangular box. Okay, if I draw that box, maybe No. This is rectangular box. This top is open. What is in the question? It is given clearly. What is that? A rectangular box open at the top. Open at the top. Therefore, actually, generally, first let dimensions. Find the dimensions of the box. Therefore, first let XYZ be the dimensions, length, breadth, and width dimensions of the rectangular box. Rectangular box open at the top. Open at the top. If it is not open at the top, what is the volume? What is the volume? What is the generally volume is XYZ. Therefore, volume of the box is what? Product of box is capital V. I'm taking this is XYZ. And what is given? It is given. Volume is given, I think, right? Given XYZ, volume is given as how much? 32 cubic feet. Next one. What we have to find? We have to find the dimensions of the box requiring least material. What is this? Least material for its construction. Means total surface area. Total surface area should Hello. Is it with? Hello.
Yes, sir.
Hello. Okay. Current పోయిందండి. So current పోయిందండి. Hotspot తో connect చేశాను. 10 more minutes. Okay. Listen. What is the question? Find the dimensions of the box requiring least means what? The total surface area of the rectangular box which is to be minimized with the least cost, with the least material. That means the total surface area, the total surface area of the box open at the top. Open at the top. This is important. Top is open. If top is not open, what is the surface area? Is S equal to, actually originally it is 2 times of xy, 2 times of yz, 2 times of zx. Surface area, right? Area, length into breadth, like that. So two positions, this one, this front and back, and down and up. But up is open now. The box is open at the top. Therefore, you delete 1, 2, and from anyone, either in yz or zx or xy. I'm neglecting in xy. Okay, this is total surface area. Here, f of xyz is what now? F of xyz is xy plus 2yz plus 2zx is to be minimized. Is to be minimized. Minimized. Subject to what condition? It is given. Subject to the condition. Subject to the condition. What is the condition? The volume is given as 32. Therefore, now, so problem comes under what? Lagrange's multipliers method. So construct the Lagrange's function. Construct the Lagrange's function L of 3 variables and only one condition is given. Therefore, one multiplier. What is that? F of xyz plus lambda into 5xyz minus c. This implies L xyz lambda is equal to, what is this? Xy plus 2yz plus 2zx plus lambda into what? Xyz minus 32. Xyz minus 32. Now, for minimum, the necessary conditions are, what is partial derivatives of L with respect to unknowns. That means dou L by dou x equals 0, dou L by dou y 0, dou L by dou z 0, and lastly With respect to multiplier also 0. Lambda 0. First dou L by dou x. Y plus 2z plus what you will get? Lambda yz you will get, right? Equal to 0. Take this as 1. Next one. This is 2z with respect to y. With respect to x over with respect to y. This is x plus 2z plus lambda into xz equal to 0. Equation 2. With respect to z, 2y plus 2x plus lambda into xy equal to 0. This is 3. And dou L by dou lambda means you will get this xyz minus 32 equal to 0. That is equal to 32. Equation 4. Now I have to solve these 4 equations for the 4 unknowns. What are the unknowns? X, y, z and lambda. So what is the logic? Logic is you can do in any manner but to solve these equations. The simple way is in first equation there is no x. In second equation there is no y. So I will take 1 into x minus 2 into y. What this becomes? See, exy plus 2zx, right? And if I subtract lambda xyz get cancelled. Minus 2 into y, this is minus xy, and minus 2zy equal to 0 you will get, right? Therefore these two also gets cancelled. And what is the common here? 2z is common. 2z is common. X minus y equal to 0. This equal to x minus y equal to 0. Why? Because dimension cannot be 0. Z not equal to 0. Therefore x equal to y. One condition over. Same logic. In second one y is not there. In third one z is not there. So 2 into y minus 3 into z. What is this? 2 into y. xy 2yz. xy plus 2yz minus lambda xy gets cancelled. And this is multiplied by z. 2yz plus 2zx. 2yz plus 2zx. So multiplied by minus equal to 0. Now these two gets cancelled. The common is what? X is common. Y minus 2z equal to 0. So y equal to 2z I am getting. Since x not equal to 0. Dimension cannot be 0. So what I am getting finally? X equal to y and y equal to 2z. Therefore x equal to y equal to 2z. X equal to y equal to in terms of z. 2z. Substitute this in last. One more equation is there. We are not utilized that. Substitute in 4. Therefore 4 implies what is that 4? xyz equal to 32 implies x equal to 2z, y equal to 2z, z is z 32. Therefore 4 z cube equal to 8. So z value is what? 2. Z value 2. Therefore when z value 2, therefore z value 2 means x value, y value both are 4. These are the dimensions. That's it. Okay. Therefore the dimensions of the rectangular box, dimensions of the rectangular box, open at the top, have R with the least material and so, x equal to y equal to 4 and z equal to 2. This is the problem. Okay. Next one. You take show that the rectangular solid of maximum, yeah, that you can do. That's solved in exercise. Some problems are there. Yeah, reverse problem for this. See, you try this. If you will not get, I will tell you. Find the dimensions of the rectangular box. Find the dimensions of the rectangular box. Open at the top. Of maximum capacity of maximum capacity maximum capacity whose surface is 432 square centimeters. 432 square centimeters. Now what is the problem here? First, same thing. Let x, y, z be the dimensions of the rectangular box. Open at the top. Okay. Then what is the given surface area is given. The total surface area is how much? 432 square centimeters. So for what is this one? Same thing, xy plus 2yz plus 2zx is how much? 430. Previously we have maximized this surface area. We have to minimize this surface area. But here surface area value is given in the problem, and what we have to get? Maximum capacity, and we have to maximize the capacity of the box. Therefore, what is the volume? Volume is what? Volume equal to xyz. This is my function fxyz. Therefore, what is the Lagrange's function? Therefore, Lagrange's function is L x y z lambda is f plus lambda into phi minus c. Simply, in a simple manner, without writing variables. xyz is now here and surface area is here. 2yz plus 2zx minus 432. Okay, you solve this. This is L of xyz comma lambda. Okay, you solve this and get the values. Write the necessary conditions and get the point xyz with lambda. That's it. Okay, these are the two models, and in the next class this Lagrange's multipliers method will be complete. Hardly 6-7 problems are there. Typical problems are there. I have to tell those problems, and I will give 4 or 5 assignment. Okay, I will stop here.
Sir, share yesterday's PDF, sir. Today's